Now we will discuss dearrangement. Dearrangements, extremely important topic. The structure of the class will be like this. First we will see what is the definition of a dearrangement. What is the definition of a dearrangement and some examples related to dearrangement. Some examples related to dearrangement. What is D of n notation? D of n notation and its proof. Dearrangement of n distinct things and its proof. Then we will find out the values of d of 1, d of 2 and so on up to d of 5. Then we will solve some practice problems based on dearrangement. This is the structure of the class. First we will see what is the definition of a dearrangement, what is some examples related to dearrangement, what is d of n and how to calculate d of n. There is a notation that is there. We will discuss the proof of that notation. Then we will find the value of d of 1, d of 2 till d of 5. You can go on and use the value, find the values for d of 6, d of 7. Some practice problems. Now, structure of the class is like this. All these 5 key points, one by one we will discuss. First key point, dearrangement. Dearrangement. In some textbooks, it is also called as the concept of mismatch. This is also called the concept of mismatch. What is this one? Suppose I took n distinct things. N distinct things are there. They have to be arranged in n places. There are n distinct things, they have to be arranged in n places such that no thing occupy its original place. This is the definition of a dearrangement. There are n distinct things are there, they have to be arranged in n places. For example, number 1 is arranged in first place, number 2 is arranged in second place, number 3 is arranged in third place, number 4 is arranged in fourth place, number 5 is arranged in fifth place. Suppose if I arrange like this, 5, 1, 4, 3, 2. 5 should be there in fifth place. It is not kept in its fifth place. 1 should be there in first place. It is not kept in first place. 4 should be kept in fourth place. It is not arranged in fourth place. Third should be kept in third place. It is not arranged in third place. Second should be kept in second place. It is not. This arrangement is called dearrangement or a mismatch arrangement. None of them is taking its original place. Suppose for example, there are 3 boys, B1, B2 and B3. They got 3 girlfriends, G1, G2 and G3. Right? No boy dances with his girlfriend. This is another example of a dearrangement. B1 has to dance with G1. B1 and G1 are couple. B2 and G2 are couple. B3 and G3 are couple. No boy dances with his girlfriend. It is also an example of a dearrangement. There are 3 letters, L1, L2, L3. L1 should get into envelope 1. L2 should get into envelope 2. L3 should get into envelope 3. No letter gets into the right envelope. Gets into its right envelope. This is also an example of a dearrangement. Dearrangement is simple language is none of the thing is there in its original position. Every everything it is altered to a different position. None of them is arranged in its original position. These I hope it is clear. Mismatch means everything is mismatched. One should be there in first position, but it is not there in the first position. Two should be there in second position, it is not there in the second position. This is called the dearrangement. Arrangement is arranged properly, dearrangement is not arranged properly, completely mismatched position. I hope the definition it is clear. Most of the students, what they will do is, there is a formula for it. D of n is given by n factorial into 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. 3 factorial, 3 is an odd number, before there is an minus, so and so on up to minus 1 power n divide into 1 by n factorial. They will by heart these formulae and they will substitute it. D of n is nothing but n factorial into 1 minus 1 factorial, 1 by 2 factorial and so on up to minus 1 power n into 1 by n factorial. Now what we'll do is, we have seen the definition of an dearrangement. We have seen the various examples of a dearrangement. We have seen the formula of a dearrangement. Now let us see the proof of these formulae. How these formulae came into picture, right? Now let me take an NCERT example. A1, A2 and A3. A1, A2 and A3. These are three distinct things. This should be there in first place. A2 should be there in second place. A3 should be there in third place. This is the original arrangement, right? So I want D of 3. What is D of 3? Number of ways of arranging. Listen carefully, sir. Once you understand, it's easy. Number of ways of arranging A1, A2, A3 such that none of them is in its position. None of them is in its original position. This is the definition of D of 3. None of them is in its original position. Now listen carefully. Let us see the proof. Suppose A1, A2, A3. This is the first position. This is the second position. A2 should be in second position. A3 should be in third position. These are the exact positions. A1 first position, A2 second position, A3 third position. N of A. N of A is nothing but number of ways such that A1 is in its first position. If A1 is in its first position, we only first A1 it is in first position. That means A2 and A3 are not in its respective positions. Not in its respective position means A2 can go to third position, A3 can go to second position. How many ways are there? 2 factorial, which is nothing but A2 can get into third position and A3 can get into second position. I hope it is clear. N of A is the number of ways of arranging such that A1 is in its first position. N of B is the number of ways of arranging where A2 is in its original position. A2 is in its second position. If A2 is in its second position, A1 can get into third position and A3 can get into first position. Again 2 factorial. I hope it is clear. Similarly, N of C, number of ways of arranging such that A3 is in its third position. If A3 is in its third position, only A3 is in its third position. If A3 is in its third position, remaining 2, A1 is not in its first position, second position, A2 is in its first position. 2 Two things, two positions, 2 factorial. I hope it is clear. Next one, n of A intersection B. A intersection B is number of ways of arranging such that A1 is in its first position and A2 is in its second position. A1 and A2 are in its right position. A1 is in first, A2 is in second. That means A3 will be in its third position. It is 1 factorial. N of B intersection C. B intersection C is number of ways in which A2 and A3 are in its positions. If A2 and A3 are in its positions, obviously A1 will be in its original position, which is 1 factorial. N of A intersection C is number of ways such that A1 and A3 on its original position. If A1 is in first position, A3 is in third position, A2 has got only 1 position, which is 1 factorial. Are you all with me? This is nothing but A2 is in its second position. If A2 and A3 on its original position, A1 is in its first position. Here it is nothing but A3 is in its third position. A3 is in its third position. Number of ways of arranging such that all the 3 are in its position. A1 is in its first position, A2 is in its second position, A3 is in its third position. There is only one way. A1 in 1, A2 in 2 and A3 in 3. I hope it is clear. N of A suggests that number of ways of arranging A1 only in first position. If A1 is in first position, A2, A3, 2 things, 2 positions, 2 factorial. Similarly, A2, A1, A3, 2 things, 2 position, 2 factorial. I hope it is clear. N of A, N of B, N of C. What do I require? I require such that A1 and A2 and A3 are not in its original position, are not in its original positions, are not in its original positions. Now what I will do is, I will use the concept of Venn diagram. This is the number of ways where A1 is in its first position. This is the number of ways in which A2 is in its second position. This is the number of ways in which A3 in its third position. This is nothing but the total number of ways. This is nothing but mu. 3 things, 3 positions. This is nothing but 3 factorial 6. What do I require? Number of ways in which A1 is not in its position, A2 is not in its position, A3 is not in its position. This dark shaded portion we require. Shaded portion, it is nothing but mu is nothing but n of A union B union C plus n of neither AB nor C. Neither AB nor C. Neither AB nor C. These only we require. These is nothing but n of neither AB nor C. Neither AB nor C. It is nothing but mu minus of n of A union B union C. A union B union C, it is nothing but, according to De Morgan's theorem, n of A plus n of B plus n of C minus of n of A intersection B minus of A intersection C minus of n of A intersection B intersection C plus n of A intersection B intersection C. I hope it is clear. This portion we require, the portion which is shaded. This is nothing but mu equivalent to n of A union B union C plus n of neither AB nor C. N of neither AB nor C, it is nothing but mu minus of n of A union B union C. Now we will write it here. N of neither AB nor C. Listen carefully, sir. Once you understand it, it's very, very easy. It is nothing but mu minus of n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. 3 people can arrange among themselves in 3 positions in 3 factorial. N of A, I got 2 factorial. N of B, 2 factorial. n of c 2 factorial minus of 1 factorial plus 1 factorial plus 1 factorial plus all the 3 are in its original position 1. These are nothing but 3 factorial. This can be written as 3 into 2 factorial. This can be written as 3 into 1 factorial plus 1. Are you all with me? Now if you see here, this can be written as 3 factorial minus, there are 3, n of a, n of b, n of c, selecting any one. A1 is in its original position, A2 is in its original position, A3 in its original position, remaining to 2 factorial. A intersection B, 2 I am selecting, out of 3, select any 2, remaining it is 1 factorial plus 1. I hope it is clear. So this can be written as, now here if I take 3 factorial common, this is nothing but 1 minus 3 into 2 factorial by 3 factorial. Minus into minus plus 3 into 1 factorial by 3 factorial. Minus into plus minus minus 1 by 3 factorial. Now if you see here, this is nothing but 3 factorial. 1 minus 6 by 6. It is again nothing but 1 by 1 factorial. 3 by 6, which is nothing but 2 factorial. This is nothing but minus 1 by 3 factorial. For 3 things, what I got? 3 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. Now it should be very, very easy for you. I hope this concept is clear. Simple application of Venn diagram can give a beautiful proof to this concept. For 3, what I got? 3 factorial into 1 minus 1 factorial, 1 by 2 factorial, 1 by 3 factorial. That means, let me write d of 3. How much we got? 3 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. Similarly, if it is 4, do the 4 set. Similarly, you will get 4 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. I hope it is clear. So what we got? D of n is nothing but 3 factorial minus of 3 into 2 factorial minus 3 into 3c1. It is 3c2 into 1 factorial and it is plus 1. If it is instead of 3, it is n factorial minus nc1. Right, remaining it is nothing but n minus 1 factorial. nc2, remaining it is nothing but n minus 2 factorial, and so on. So if I take n factorial common, this is nothing but n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial minus 1 power n into 1 by n factorial. I hope the dearrangement proof is extremely clear to you. A very, very simple concept. 99% of the teachers don't teach the proof behind this concept. But if you forget the formula also, you can do it by using this way. I hope it is clear why d of 3 is 3 factorial into 1 minus 1 by 5 factorial. N of a, it is the number of ways where a1 is in its original position. N of b, number of ways in which a2 is in its original position. Number of ways in which a3 is in its original position. A and b, b and c, a and c. I want none of them should be in its original position, which is neither of a, b nor c. Neither of a, b nor c is mu minus of n of a union b union c. I hope the idea it is clear. So now we will write down d of n, it is nothing but n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial minus 1 power n into 1 by n factorial. Suppose one question, examples. First question, there are 3 letters L1, L2 and L3. These letters should not go into the right? The right envelope. No letter should get into the right envelope. If the question is there, no letter should get into right envelope. Right envelope. What will be the answer? Right envelope. D is nothing but D of 3. D of 3, it is nothing but 3 factorial into 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. 3 factorial, it is 6. 6 into 1 minus 1 by 1 plus 1 by 2 minus 1 by 6. 1 minus 1 cancel. These is nothing but 3 minus 2. These is nothing but 3 minus 2. I hope it is clear. No letter should get into the right envelope. Another example. Suppose if it is 4 letters are there. 4 letters should not get into their respective envelope. These is nothing but D of 4. 1 minus 1 factorial, it is 1. So these is nothing but 4 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. 24 into 1 by 2 minus 1 by 6 plus 1 by 24. So it is 12 minus 4 plus 1. Answer, it is 9. There are 9 ways are there where 4 letters cannot get into the 4 right envelopes. There are number of ways in which 3 letters do not get into their respective envelope. T of 3 value, it is nothing but 2. Now we will write this, it will be useful. N and D arrangement of N. N and D arrangement of N. If N is 1, so 1 letter is there, 1 envelope is there, right? Not going, it is 0. It is 2. D of 2 is there. L1, L2, E1, E2. L1 can get into E2, L2 can get into E1. D of 2, it is 1. D of 3, just now we got it as 1. D of 4, we got it as 9. D of 5, till here it is extremely important for your examination. D of 5 is 5 factorial. 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. These is nothing but cancel. 120 into 1 by 2 minus 1 by 6 plus 1 by 24 minus 1 by 120. These is nothing but 60 minus 20 plus 5 minus 1. D of 5 value, it is nothing but 44. Very, very important. D arrangement. N1 0, N2 1, N3 2, N4 9 and N5 44. I hope the idea it is clear, right? Now we will see. We have seen the definition, we have seen the examples, we have seen the proofs, and we have seen the values of D arrangement of 1, 2, 3, 4. Now let us take some practice problems.